A black hole is a region in space where the gravitational pull is so strong that nothing, not even light, can escape from it. It is formed when a massive star collapses under its own gravity at the end of its life cycle. Black holes can come in different sizes, from stellar black holes with a few times the mass of our Sun to supermassive black holes found at the centers of galaxies, which can be millions or billions of times more massive than our Sun. Black holes have several key features, including their event horizon, which is the boundary beyond which nothing can escape, and their singularity, which is the central point where the mass is concentrated. The study of black holes has been crucial in our understanding of general relativity and the nature of space-time. 1. Definition. A black hole is a region in space where the gravitational pull is so strong that nothing, not even light, can escape from it. 2. Formation. Black holes are formed when massive stars exhaust their nuclear fuel and collapse under their own gravity or through the merging of other black holes. 3. Types. There are 3 main types of black holes: stellar black holes, intermediate black holes, and supermassive black holes. 4. Stellar black holes. These are the most common type and have masses ranging from a few times to several tens of times that of our Sun. 5. Intermediate black holes. Their masses lie between stellar and supermassive black holes, but there is still ongoing research about their existence. 6. Supermassive black holes. These are found at the centers of most galaxies and can have masses millions to billions of times that of the Sun. 7. Event horizon. The boundary of a black hole is called the event horizon, beyond which anything that crosses cannot escape its gravitational pull. 8. Singularities. At the center of a black hole there is a point of infinite density called a singularity. 9. Observing black holes. Black holes are challenging to observe directly, but scientists use various methods like observing their effects on nearby matter or detecting gravitational waves produced by their mergers. 10. Hawking radiation. Black holes can emit radiation known as Hawking radiation, which is a theoretical process proposed by physicist Stephen Hawking. It suggests that black holes slowly lose mass over time. 11. Size and scale. Black holes can vary significantly in size. Stellar black holes typically have a radius of a few kilometers, while supermassive black holes can have a radius of millions to billions of kilometers. 12. Time dilation. Near a black hole, time dilation occurs due to its strong gravitational field. Time moves slower for an observer closer to the black hole compared to those further away. 13. Accretion disk. Surrounding a black hole, there is often a swirling disk of gas and dust called an accretion disk. As matter falls into the black hole, it heats up and emits X-rays and other forms of radiation. 14. Galactic evolution. Supermassive black holes play a crucial role in the evolution of galaxies. Their gravitational influence affects the motion of stars and gas within galaxies. 15. Intermediate mass black holes, IMBH. While not yet definitively confirmed, intermediate mass black holes are believed to exist with masses between stellar black holes and supermassive black holes. 16. Information paradox. Black holes are also involved in a deep theoretical puzzle known as the black hole information paradox, which revolves around the conservation of information and quantum mechanics. 17. Black hole mergers. When black holes are part of binary systems, they can merge together due to gravitational wave emission. This phenomenon has been detected by gravitational wave observatories. 18. Wormholes. There is speculation about the existence of theoretical wormholes which could potentially connect distant parts of the universe through shortcuts, but their existence remains purely hypothetical. Remember that our understanding of black holes continues to evolve as researchers make new discoveries and refine their theories. If you have any specific questions or want more information on a particular topic, feel free to ask.